In this lesson, we will consider the question of real numbers and the number line. What is real number? Real number is the set of all possible numbers that we use in our daily life. In other words, if you can give me a number, that number will be a real number. The set of all possible numbers that we use in our everyday life to describe every activity is a real number. Alright? Now, we will now consider different groups of numbers that make up the set of these real numbers. The real numbers, the set of real numbers can be divided into many groups. We are now going to see the various groups that make up the real numbers. The first type of numbers is natural numbers. What is the meaning of natural numbers? In the very olden days, when we started using numbers to count, what do you think is the first number people in those days used? The first number? Well, the first number will be 1, because they can see 1 stone, 2 stones, 3 stones, 1 egg, 2 egg, and so on. So the first number was 1, and from 1 you go to 2, 3, 4, 5. These numbers are called natural numbers. Now look at the statement I have made. Natural numbers consist of discrete counting numbers. What is the meaning of discrete numbers? Now, discrete numbers means from one number you go directly to the next one. You don't have anything in. Now, when I use natural numbers or discrete numbers to count, look at this. 1, 2, 3. I have 3 blocks in my hand. Then 4. When I count, I go from 1 to 2. There is nothing in between. You see, I don't have 1.1, 1.2 or 1.3. From 1 I go to 2, then to 3. These kind of numbers are called discrete. There is nothing in between. So natural numbers consist of discrete counting numbers. Numbers that are used for counting whole things. Now let's start from 1. We represent the set of all natural numbers by the uppercase N. So what does the uppercase N represent? It represents the set of all natural numbers. Tell me, how many such numbers are there in that set? There are infinite numbers, starting from 1. The set of natural numbers is written as, look at the way we write the set of natural numbers. N equal to, you see, these braces are used to represent a set. And this is the way we read it. N equal to a set of 1, 2, 3, 4, 5. And look at these dots there. It tells me that it goes indefinitely to the right all the way to positive infinity. The 3 dots at the end indicates that these numbers continue indefinitely to the right. Now, all types of numbers can be represented on a number line where the position of each number is fixed. I'm sure you have heard about a number line and what a number line is. What is a number line? A number line is a line where the position of each number is fixed. Alright? Now, let's represent the set of natural numbers on a number line. Now, here is the number line. Now fix the position of the number. This is my 1. Where will my 2 be? I go to the right. That is my 2. And I go to the right again. That is my 3, my 4, 5, and look at the arrow there. What does the arrow represent? We go indefinitely to the right. Now, this is how we represent discrete counting numbers. From 1, we jump to 2. In other words, the set of natural numbers do not contain anything in between 1 and 2. It does not contain anything in between 2 and 3. It only contains these discrete counting numbers 1, 2, 3, 4, 5, and so on to positive infinity. Natural numbers on a number line look like this. Alright, the second type of numbers that make up real numbers is the set of whole numbers. The set of whole numbers. Now, the set of natural numbers along with 0 make up the set of whole numbers. You see, 0 was discovered a lot later. Earlier on, the concept of 0 was not understood because you count only if you have things. If you don't have things, you don't count. So the idea of 0 was not understood by mathematicians early on. It was an Indian mathematician who discovered that concept of 0. So when you put 0 along with the set of natural numbers, they are called whole numbers. So the set of whole numbers can be written as, look at the symbol we use for the set of whole numbers, W. And how do you read this? W is a set of 0, 1, 2, 3, 4, 5 and goes indefinitely all the way to positive infinity. Now, the 3 dots again indicate that we continue all the way to positive infinity. The set of whole numbers can be represented on the number line in a similar way we did with the set of natural numbers. The only difference between whole numbers and natural numbers is that whole numbers also include 0. So how will that look like on the number line? We start from 0, then 1, 2, 3, 4, 5, and goes indefinitely to the right. The set of whole numbers actually contain the set of natural numbers. Is that right? Look at the set of natural numbers here. The set of natural numbers is a part of the set of whole numbers. And so, if I make a statement, listen to my statement and tell me if this is true. All natural numbers are whole numbers. Yes, all natural numbers belong to the set of whole numbers. Can I make the statement the other way around? Alright, tell me if this statement is true. All whole numbers are natural numbers. Is it true? No, because 0 is a whole number and 0 is not a natural number. Alright, so you got to understand the concept carefully. Okay, the third type of numbers is called integers. What is the set of integers? For each number on the right of 0 on the number line, there is a corresponding number to the left of 0. Do you understand that? Well, 0 is at the middle of the number line. And if you go to the right, you see the natural numbers. For each natural number on the right of 0, there is a corresponding number on the left of 0. What will be that number? The natural number 1 is 1 more than 0, and it appears to the right of 0. Now the number that is 1 less than 0 is called -1. So -1 is the number that is 1 less than 0, and where will that appear on the number line? It will appear on the left of 0, and we call -1 is the opposite of +1. That means for every natural number on the right of 0, you have the opposite of those numbers to the left of 0. Every natural number has its corresponding opposites. The natural number 5 has an opposite that is -5. Every natural number has its opposite that appears to the left of 0. The set of all natural numbers and their opposites, and along with 0, form the set of integers. So, what is the set of integers? The set of integers contain all natural numbers on the right of 0, all the opposites of the natural numbers to the left of 0, and also 0. That is the set of integers. So, if I ask you to give me a definition of the set of integers, what would be that? Try giving me a definition. Integers is the set of all natural numbers along with their opposites and 0. You see, all those together makes up the set of integers. Look at how I write the set of integers. Integers is represented by the letter I, capital I. I is a set of, where does it start? Where is the starting point for the set of integers? It starts all the way from -infinity, all the way from -infinity to -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, goes all the way to positive infinity. And all these numbers put together is called the set of integers. Now, let's mark them on a number line. How does the set of integers look like on a number line? We start at 0. We got 1, 2, 3, 4. And now, here we have the set of integers to the right of 0. And each of these integers has its opposites on the other side. -1 is the opposite of 1. -2 is the opposite of 2. -3 is the opposite of 3. -4 is the opposite of 4. And so on. Now look at the set of integers. It starts, where is the starting point for the set of integers? -infinity on the left, all the way to positive infinity. And all these are discrete numbers, nothing in between. Alright, the set of integers extend to positive infinity on the right. It starts from -infinity and goes all the way to positive infinity. So, and -infinity on the left and positive infinity on the right. Now look at the way we write infinity. Alright, how do we write it? Well, this is the way we write infinity. Alright, infinity, infinity, infinity. Now, -infinity on the left and positive infinity on the right. Integers start from negative infinity and go all the way to positive infinity. Now, remember, only the discrete numbers are included in there. The set of integers contain the set of natural numbers and the set of whole numbers. Look at this. The set of integers is part of, listen to that again. The set of natural numbers is part of the set of integers. Similarly, the set of whole numbers is a part of the set of integers. So I can say all natural numbers are integers. All whole numbers are integers. But can I say that all integers are natural numbers? No, I cannot say that. Okay, all whole numbers are integers. The fourth type of number is called a rational number. A rational number. What is a rational number? Any number of the form A over B. I want you to pay attention here and learn it well. The meaning of rational number. Any number that can be written in the form A over B is a rational number where A and B both are integers. In other words, let me show you how that works. Any number of the form A over B, where A is an integer and B also is an integer. Look at this. Therefore, 5 over 7 is a rational number. Negative 3 over 5 is a rational number. Right? 0 over 3 is a rational number. Well, 5 over 2 is a rational number. But, watch this. 3 over 0 is not a rational number. Well, in here, B cannot be 0. You see, the reason why B cannot be 0 is that you cannot divide a number by 0. Dividing a number by 0 is meaningless. And therefore, you cannot have 3 divided by 0 or 5 divided by 0. We say, this is undefined. This is not a defined number. So what is the definition of an integer? An integer is a number written of the form A over B, where A is an integer, B also is an integer, but B cannot be 0. That is the definition of an integer, of a rational number. Now, why is it called a rational number? What is rationality? Do you know what word rational means? Suppose we say, that particular person, A, that man is a rational man. What does that mean? He is rational. Well, it means what he is going to do, we can more or less guess. You see, a rational person is somebody whose behavior can be predicted. In the same way, a rational number is a number whose behavior can be predicted. Now, what kind of behavior has a rational number has? Now, I'm going to show you some numbers. Look at this. 11 over 8 is a rational number, and if you write it as a decimal, if you have a calculator, try this. 11 over 8, you will get it as 1.375. Alright? 11 over 7 is another rational number. Is that right? any number of the form an integer divided by an integer. 11 over 7 is a rational number. Now, when you write it in its decimal form, now I used my calculator. My calculator can give me long decimal forms. Now look at the number I got. 1.571428, 571428. Now it goes on like this. 571428, 571428. It goes on and on without any end. You see? Is that a predictability? Yes, it's a predictability. And look at this number, 3 divided by negative 11. If you work it out on your calculator, it gives me negative 0.272727272727. Goes on and on and on. Is that a predictability? Yes. And look at this. 1 over 3 is 0.333333, and so on. Negative 24 over 5 is negative 4.8. 22 over 7, another rational number, is 3.142857, 142857, 142857. It goes on repeating. So tell me, what is the predictability of a rational number? All these are rational numbers. An integer divided by an integer. So the predictability of a rational number is either a repeating decimal. When you write a rational number as a decimal, it will either be a repeating decimal like this, or like this, or like this, or like this, or it will be a terminating decimal. Look at this, negative 4.8. It stops there, terminates there. 1.375, it terminates there. So this is the characteristic of a rational number. A rational number has a predictable behavior. What is that predictable behavior? It is either a repeating decimal or a terminating decimal. All rational numbers fall into one of these categories, and therefore its behavior is predictable. Now, a repeating decimal of the form 0.3333 and so on is written using a shorter notation. Look at this. 0.3 with a line on top of 3. The line on top of 3 tells you that that 3 is repeated. And 1.571428, 571428 is written like this. 1.57428 with a line on top of 57428. What does that mean? It means that 57428 is repeated indefinitely. All rational numbers have their fixed positions on the number line. Alright, let me show you positions of some number line. What does this number 22 over 7 is here? 3.14, it goes on and on and on. It's somewhere here, that rational number. You see? Now, another number, 11 over 8. All these numbers we talked about earlier, I'm now picking them up. 11 over 8 is right here. That will be 1 point something. Is that right? Yes. Now look at the position of negative 7 over 8. Now, can you tell me where exactly that negative 7 over 8? Is it going to be to the right of negative 1, or is it going to be to the left of negative 1? Where do I mark its position? Negative 7 over 8. Actually, it is greater than negative 1. So, it will be right there, slightly to the right of negative 1. Alright, how about negative 24 over 5? Negative 4.8. You see, right there, that's negative 4.8, just before negative 5. So, all rational numbers have their fixed positions on the number line. And it goes to the right and left indefinitely. That means you have millions and trillions of rational numbers that can be put on the number line. Let me ask you, is negative 2 a rational number? Negative 2? Yes, negative 2 is a rational number. Now, because negative 2 can be written as negative 2 over 1. 5 can be written as 5 over 1. That means all integers are rational. Negative 2 is a rational number. Negative 9 is a rational number. 0 is a rational number. 1, 2, 3, they are all rational numbers. All integers are rational numbers. All natural numbers are rational numbers. All whole numbers are rational numbers. All integers are rational numbers. We know their behavior. We know we can predict their behavior. Okay. Natural numbers, whole numbers, and integers are all rational numbers. What about irrational numbers? Just like a person can be rational, another person can be irrational. We say, don't go anywhere near that person. You never know what he's going to do next. He might hit you, right? Irrational. Now, unpredictable behavior. Well, can numbers have that characteristic? Can a number be unpredictable? Well, numbers that do not form terminating decimals or repeating decimals are irrational numbers. There are some numbers whose behavior there is no way to predict. Now, what kind of numbers are there? Now, give me some examples. Square root of 2. If you put down that on your calculator and try to find the decimal value, you will see there is no pattern for that decimal value. Square root of 2. 1.4142637892015. There is no predictability for its value. It doesn't repeat, it doesn't terminate, it is irrational. Square root of 5 is irrational. Square root of 7 is irrational. Negative square root 11 is irrational. Another irrational number is the number called pi. That is irrational. Now, do you know what pi is? Let me just take a minute and explain to you what pi is. Now, suppose you draw many circles. You see, I'm going to draw many circles. Alright. Now, if you measure the distance around the circle, it's called a circumference. You know what a circumference is? Circumference is the distance around a circle. If you divide that circumference by the diameter, you see, you draw any number of circles. You can draw thousands and thousands of different circles. You measure the circumference of each circle and divide it by its diameter, you will always end up with the same number. It is that number that is called a natural constant, because it is a constant for nature. Any circle, the circumference divided by the diameter is a constant, and that constant is pi. And unfortunately, that pi is an irrational number. When you put it in your calculator, it doesn't show any predictability, no termination, no repetition. It will go on and on and on without any pattern. Now, such numbers are called irrational numbers, and these numbers show no sign of predictability. All right? An irrational number shows no predictability. Now, what are the types of numbers we have talked about so far? We talked about natural numbers, whole numbers, integers, rational numbers, and irrational numbers. Now, if you put all these numbers together, all these numbers are numbers that we use in our everyday life, and all these numbers together is called the set of real numbers. So real numbers contain all these numbers. Natural number is a real number. Whole numbers are real numbers. Integers are real numbers, right? Rational and irrational numbers are real numbers. The set of real numbers are made up of all rational and irrational numbers. That means if you can give me a number, that will be a real number. When you mark real numbers on a number line, there are no gaps between them. In other words, you see, the real numbers are so continuous. If I mark two numbers on a number line, you will be able to write thousands of numbers in between the numbers that I did. So how would you draw a number line for real numbers? Real numbers simply go from negative infinity to positive infinity. You see? So you will represent the real numbers by simply a straight line, because there is no gap between any two real numbers. For example, watch this. Suppose I write a number here, I'm going to call it 1.1. That's a rational number. And this is 1.11. Now tell me, how many numbers are there in between 1.1 and 1.11? Well, there are billions and trillions of numbers in between here. So, is there any sense in saying that there is gap between numbers in a real number line? No. There are no gaps actually. So, the number line for real numbers is a continuous line extending from negative infinity to positive infinity. Okay, that is the set of real numbers. That's correct. The interval from negative infinity to positive infinity, look at the way we write that interval. Parenthesis, negative infinity to positive infinity, close parenthesis. This is called an interval notation. The numbers in the interval from negative infinity to positive infinity, all the numbers in that interval are real numbers. That means the interval negative infinity to positive infinity contains all real numbers. Now look at that. If this is all real numbers, that means if you put all possible numbers in the world in here, that will be the set of real numbers. The set of all real numbers. The set of all real numbers can be divided. I'm now going to start from real numbers and go back to where we came from. The real numbers can be divided into rational and irrational. Look at this. I'm going to put rational numbers on the left. Give me some examples of rational numbers. And irrational numbers on the right side. Look at some examples of rational numbers. 11 over 8. 2/3. 5. Is 5 a rational number? Yes, it is. Because it can be written as 5 over 1. -2 is a rational number. -3.414 is a rational number. 0 is a rational number. Square root 7 is an irrational number. Square root 23 is an irrational number. Square root 2 is an irrational number. Alright, pi is an irrational number. Alright, now rational numbers can be, is made up of integers, that's right. Rational numbers are made of integers. Now give me some examples of integers. Integers is the set of all natural numbers, their opposites with 0. They are integers. And whole numbers are numbers from 0, 1, 2, 3, 4, 5, and so on. There you got 0, 3, 5, and so on. And if you take part of the whole numbers, that is your natural numbers. You see, we now started and went all the way back where we started. Okay, I want you to look at and learn the various concepts of these. Alright? Let me give you a simple question. Look at the set of numbers I have given you. List the natural numbers from the set of these numbers given. What are the natural numbers in here? Now, remember, natural numbers are discrete numbers starting from 1. So, -5.3, is that a natural number? -5, is that a natural number? No. -square root 3, is that a natural number? Alright? Okay. What is the natural number here? There is only one natural number here. That is 3. 3 is the only natural number in this set. Okay? Now, list the whole numbers from this set of numbers. What are the whole numbers there? Well, whole numbers also include 0. Along with natural numbers, you put 0, you get the set of whole numbers. So what are the whole numbers in this given set? 0 is a whole number, 3 is a whole number. So 0 and 3 are the whole numbers. How about this? List the integers in the set. Integers also include the opposites of natural numbers. So if you come from the left, you see -5 is an integer. -1 is an integer. 0 is an integer. 3 is an integer. An integer contains all natural numbers, the opposites, and then 0. So -5, -1, 0, and 3 are the integers in that set. Alright, let's do another one. List the rational numbers from the set of rational numbers. Remember, all integers are rational. Right? -5.3 is a rational number. -5 is a rational number. -1 is a rational number. -1/9 is a rational number. 0 is a rational number. How about 1.2? Yes, it is a rational number. 1.8 is a rational number. 3 is a rational number. So rational numbers are negative 5.3, negative 5, negative 1, negative 1 over 9, 0, 1.2, 1.8, and 3 are all rational numbers. Well, what are then the irrational numbers? Well, obviously, numbers in the square root will be irrational. Square root, negative square root of 3 and square root of 11 are irrational numbers. Now, you must be able to do an exercise like this. Okay, now tell me, list the real numbers in this set. Real numbers. I told you earlier, if you can write down a number, that number will be real. That means all these numbers, rational as well as irrational, form part of the set of real numbers. Okay? Alright, graph the following numbers on a number line. 2, 6, negative 3, negative 5. Can you do that? Draw a number line and mark the positions of these numbers. Now here is the number line, 0 at the middle. You got positive numbers to the right, negative numbers to the left. It goes from negative infinity to positive infinity. The position of 2 is right here, 6 is there, negative 3 is there, and negative 5 is there. Now you notice that sometimes the positions I marked, I will not be able to mark it exactly where I want. The computer doesn't let me do that sometimes. You can see that got displaced slightly from negative 5. Okay, graph the following numbers again on the number line. 5 and 1/4, 4 and 5/9, negative 2 and 1/3, negative 6 and 2/5. Now, can you do this? 5 and 1/4. You can see 5 and 1/4 will be approximately here. That's 5 and 1/4. 4 and 5/9. You must know 5/9 is a little more than a half. So 4 and 5/9 will be a little more than 4 and a half. It's right here is 4 and 5/9. Alright. Where will be negative 2 and 1/3? This is negative 2. Will negative 2 and 1/3 be to the left of it or to the right of it? Well, it will be over here. Negative 2 and 1/3. Where will negative 6 and 2/5 be? Negative 6 and 2/5 is over here. So any real number can find a position on the number line, and you must be able to mark the numbers on the number line. We will now talk about properties of real numbers. What are some of the important properties of real numbers? The first property says every real number has an additive inverse. An additive inverse. What does that mean? A number added to its additive inverse will always give you 0. You see, a number 5 added to its additive inverse, negative 5. 5 added to negative 5 gives you 0. 10 added to negative 10 gives you 0. So, tell me, what is the additive inverse of 20? Additive inverse of 20 is negative 20. 20 added to negative 20 gives you 0. a number and its additive inverse are at equal distances from 0. Is that right? 20 is 20 units to the right of 0. Negative 20 is 20 units to the left of 0. You see? A number and its additive inverse are at equal distances from 0, one on the right and the other on the left. Additive inverse of 4 is negative 4. Alright? So additive inverse of 4 is negative 4. In fact, additive inverse of a number is its opposite. Is that right? Yes. Additive inverse of 3 over 2. This is 3 over 2 here. What is the additive inverse of 3 over 2? Is negative 3 over 2. There you are. Additive inverse of square root of 40 is negative square root of 40. You see? The opposite. Now, where is square root of 40? Square root of 40 is approximately here. And negative square root of 40 is over there. So, the number and its additive inverse are at equal distances to the right and left of 0. Additive inverse of negative 9. Look at this. If the number is negative 9, its additive inverse is positive 9. That's right. The second property of a real number is what we call the double negative property. I want you to understand these because we're going to use them as we go on. For any real number x, negative of negative x is positive x. You see? What does it mean? Negative of negative x means subtract a negative number. Now tell me. Now, when will your money be negative? Have you ever thought of that? Your money becomes negative when you start borrowing money. When you don't have any money, that means you don't have any money in the bank, you have no money in the pocket, you haven't borrowed any money from there. So if I ask you how much money you have, you can safely tell me 0. But 10 minutes later, you go and borrow $10 from your friend. So I come and ask you how much money you have now. Well, if you tell me $10, you'll be wrong. You don't have $10. You borrowed $10 and spent it. So how much money you have now? You owe $10. So the money you now have is negative. You are now in the negative territory. All right. How do you subtract from it? You see, you owe $10. All right. Now you subtract a negative. You see, if a debt is considered negative, then an asset is positive. Now, how do you subtract a negative? Subtracting a negative is paying off your debt. You suppose you go and pay back $5 to the person. What will be then your debt? You had $10 debt, you paid off 5, now you are left with negative 5. Is that right? So the negative 10 you had initially, the money you had was negative 10. And what you did, you subtracted your debt. You subtracted 5 of that debt. You see, you subtracted $5 of your debt. Now, when you subtract a debt, your asset is actually increasing. And this is the same as 10, negative 10 plus 5, which is negative 5. So, subtracting a debt means you paid off $5. That means your debt is now $5. So subtracting a negative will give you a positive value. Double negative property is a very important property. Subtracting a negative number is the same as adding a positive number. 5 minus negative 2. Look at that. Subtract a negative. What is that? 5 minus negative 2 is the same as 5 plus 2. And that's 7. Simplify. Let's do a simple problem. 2x minus negative x plus 2 times negative x minus negative 3. I want you to apply the double negative property here and simplify this. What do? Look at the red lines I have used here. Double negative. So 2x minus negative x will become positive x. And here minus negative 3 will become a positive 3. So that will be 2x minus negative x become plus x. And look at this. 2 times negative x, a positive number multiplied by a negative number becomes a negative number. 2 times negative x is minus 2x. Minus negative 3 is positive 3. Double negative property. Okay? And that will be 2x plus x minus 2x. Look at that. 2x minus 2x will cancel. And the result is x plus 3. Multiplying two negative numbers gives a positive value. That is what double negative means. Negative of negative x. Actually, negative of negative x is the same as negative 1 times negative x. So multiplying negative 1 by negative x gives you a positive number. Multiplying negative 1 and negative x gives you a positive x. Now, this is another way of stating the double negative price. Negative of negative x means negative 1 times negative x. Now, whereas 2 multiplied by negative x, a positive multiplied by negative gives you a negative. 2 times negative x is negative 2x. But negative 2 times negative x, a negative number multiplied by a negative number is a positive number. Negative 2 times negative x is positive 2x. Alright, let's simplify this. Negative 2 in brackets. 2 minus, this is braces. 2 minus bracket, 3 minus x times 2 minus 5, parenthesis end, bracket end, braces end. Where do we start here? You always start inside the parenthesis. So first simplify 2 minus 5. What is 2 minus 5? 2 minus 5 is negative 3. So leave everything else the same. Just simplify this. This 2 minus 5 now is negative 3. Now what you have here in my red coloring is negative x times negative 3. So simplify that. Apply the double negative property here. That will give you negative 2, braces, 2 minus, bracket, 3, negative x times negative 3 is positive 3x. You see that? This now becomes positive 3x. And now, what do? Distribute the negative. I don't think we have actually done that, but distributing the negative means this negative belongs to this 3, also belongs to this 3x. That's why that negative is outside the bracket there. So that gives me negative 2 braces 2 minus 3 minus 3x. You see, that negative belongs to this 3, also this 3x. And now simplify the inside. What will that become? What is 2 minus 3? 2 minus 3 is negative 1. So that now becomes negative 2 in braces, negative 1 minus 3x. Okay, the next one, we distribute the negative 2. Now, this negative 2 is sitting outside the braces means this negative 2 ought to be multiplied with each of these numbers. Alright, tell me, what is negative 2 multiplied by negative 1? That would be negative 2 multiplied by negative 1, and then negative 2 multiplied by negative 3. Alright, apply the double negative property. Negative 2 multiplied by negative 1 is positive 2. And negative 2 multiplied by negative 3x is positive 6x. So the result of simplifying this quantity is 2 plus 6x. I want you to look at this one more time and learn it. The next property is called the absolute value property. Absolute value property. What is the meaning of absolute value of a number? Absolute value of a number is the distance of that number from 0. Now, what is the distance of 5 from 0? 5 is here. The distance of 5 from 0 is 5 units. Is that right? Alright. So, this is the distance of 5 from 0. Let's call it 5 units. It can be 5 meters or 5 kilometers. It will be 5 units. Now, the distance of 5 from 0, therefore, is 5 units. That means absolute value of 5 is 5. You see? What is the meaning of absolute value of a number? Absolute value of a number is the distance of that number from 0. The distance of the number 5 from 0 is 5. Therefore, we say absolute value of 5 is 5. And look at the way we write it. If you don't know, I'm sure most of you know how to write the absolute value of a number. You see, we put 2 vertical lines and write the number in between and read it as absolute value of 5 equal to 5. In other words, it tells me that the distance of number 5 from 0 is 5. Absolute value of 5 is 5. Okay, now tell me, what is the distance of negative 5 from 0? The distance of negative 5 from 0 is also 5 units. You see? Number 5 is 5 units away from 0 on the right. Negative 5 is 5 units away from 0 on the left. So 5 and negative 5 are at equal distance from 0. That means, what is the absolute value of 5? The distance of negative 5 from 0 is also 5. That means the absolute value of negative 5 is also 5. How do we write it? Absolute value of negative 5. Within the vertical line, write negative 5. Absolute value of negative 5 equal to 5. Now, that tells you something, isn't it? That absolute value of a number cannot be negative. Absolute value of a number is always positive. Absolute value of negative 100 equal to 100. The distance of negative 100 from 0 is 100. Well, absolute value of a number is always positive. Absolute value is never negative. Look at this. Absolute value of 11 is the same as absolute value of negative 11, which is the same as 11. Now, let's simplify this number. Negative of absolute value of negative 7. Tell me, where will you start the simplification process? You will use by applying the double negative property inside. Negative 7. What is negative 7? Negative 7 is positive 7. So I replace this quantity, negative 7, as 7. Negative of absolute value of negative 7 is the same as negative of absolute value of 7. And that will be negative 7. Alright? Let's now do another simplification. Simplify negative absolute value of 3 minus 6. Can you do that in your mind? First of all, simplify 3 minus 6. What is 3 minus 6? 3 minus 6 is negative 3, right? 6 take away from 3 is negative 3. Absolute value of negative 3 is positive 3. And negative of positive 3 is negative 3. Can you think like that? Alright. First, we said 3 minus 6 is negative 3. So, negative absolute value of 3 minus 6 is negative of absolute value of negative 3. Now, absolute value of negative 3 is positive 3. So, that will be this negative, we haven't touched that, this negative, and this is positive 3. That makes the answer negative 3. Okay? Which of the following is the smaller of the two? Negative 7, negative 2, and negative 7. In order to determine whether a number is smaller or greater, you need to place each number on the number line. Now remember, on the number line, the smaller numbers are on the left and the bigger numbers are on the right. So when you place the numbers on the number line, the number on the left will be smaller than the number on the right. Can you place these two numbers on the number line and tell me which comes on the left and which comes on the right? Well, obviously negative 7 is to the left of negative 2 on the number line. Is that right? Yes, of course. On the number line, if you move to the left, the numbers get smaller and smaller. So here we have negative 7 over here and negative 2 over here. Negative 7 is to the left of negative 2. So which is greater? As you go to the left, the numbers get smaller. As you go to the right, the numbers get bigger. There you got bigger numbers and smaller numbers. So when you want to decide which is greater, which is small, place it on the number line, and whatever number comes on the left is the smaller, and whatever is on the right is the bigger. Negative 7 comes to the left of negative 2. Therefore, negative 7 is smaller than negative 2. And we write it like this. Negative 7 is less than, you know that symbol, is that right? Is less than negative 2. Alright, now tell me which is larger, negative 20 or negative 21? Well, obviously, if you go to the left, negative 21 will be to the left of negative 20. So, negative 20 is to the right of negative 21. And therefore, the number on the right is greater than the number on the left. Negative 20 is larger than negative 21. Okay, and we write it like this. Negative 20 is greater than negative 21. Which of the following is smaller? Well, in order to determine this, first we simplify it. What is negative absolute value of negative 2? Can you tell me what that is? Negative absolute value of negative 2. Absolute value of a number is always positive. So this is positive 2. And this negative will make it negative 2. Alright, this is positive 3. And using the negative, it becomes negative 3. Negative absolute value of negative 2 is negative 2. Similarly, negative absolute value of negative 3 is negative 3. Now the question is, which of them is smaller? Negative 2 or negative 3? Which is smaller? Which comes to the left? Negative 3 comes to the left of negative 2. Therefore, negative 3 is smaller than negative 2. Negative 3 is less than negative 2. Alright? Which of the following is larger? Absolute value of negative 8, absolute value of negative 9. Can you tell me just like that, which of them is larger? Knowing that absolute value of a number is always positive. So this is positive 8, this is positive 9. And you know 9 is greater than 8. Therefore, absolute value of negative 9 is greater than absolute value of negative 8. There you are. Okay, let's move on. Which of the following is smaller? Absolute value of 7 minus 2. Absolute value of 8 minus 3. Alright, give me the values of this. What is the absolute value of 7 minus 2? 7 minus 2 is 5. Absolute value of 5 is 5. Similarly, 8 minus 3 is 5. Absolute value of 5 is 5. Here you are. That means they are both equal, right? That's right. So absolute value of 7 minus 2 is equal to absolute value of 8 minus 3. Is the statement negative 8 greater than negative 2 true? Is this statement true? Well, always a greater number comes to the right. A smaller number comes to the left. If you say negative 8 is greater than negative 2, we are saying that negative 8 comes to the right of negative 2. Is that true? No. Therefore, this is not a true statement. Since negative 8 comes to the left of negative 2, negative 8 is less than negative 2. So this is not a true statement. Another one. Decide whether the statement is true or false. Absolute value of 13 minus 8 less than or equal to absolute value of 7 minus 4. Okay? First of all, simplify each of these. 13 minus 8 is 5, is that right? And absolute value of 13 minus 8 is therefore absolute value of 5. That will be 5. Alright, let's simplify this. 7 minus 4 is 3. Therefore, absolute value of 7 minus 4 is absolute value of 3. That is 3. Alright? Is 5 less than or equal to 3? This is 5 and this is 3. So if this statement is true, then 5 is less than or equal to 3. Is it true? Since 5 less than or equal to 3 is a false statement, this statement is false. I hope you understand the way we do this. Decide whether the statement is true or false. Negative 6 less than or equal to negative of negative 3. Well, you notice we need to apply the double negative property to simplify here. What is the right hand side equal to? Negative of negative 3. Double negative property tells me that negative of negative 3 is positive 3. So, this is the same as negative 6 less than or equal to 3. Now, is this a true statement? Well, yes, because negative 6 is less than 3. And therefore, that statement is true. Okay, now we have actually covered all the properties of real numbers. Now, in another lesson, we will continue with the discussion on the properties of real numbers. And we will see that a little later. But at the moment, I want you to go back. Remember, every time you watch a lecture, you need to go back and do your homework. And make sure you can do all those questions. And as I told you earlier, it's only by doing you learn. You don't learn by listening to me talk. You learn when you do it on your own. So go back and do your homework. And I'll see you for the next lesson later on.